Hi, I'm Vivek from IvyProSchool, and in this video I'd like to talk to you about linear algebra because linear algebra is a very important concept in machine learning. Mostly in machine learning we deal with matrices and vectors so that we can leverage their properties for ease of mathematical computation. So straight to it then. What is a matrix? A matrix, simply put, is an array of two-dimensional elements. So a matrix A can be represented as 1, 2, 3, something like that. Now, to make this clear, let us take the example of a data set. Suppose I have age, I have income, and I have expenditure. So for a particular person, suppose age is 23, income is in thousands, 10,000, and expenditure is 8,000. For someone who is 25, income may be 20,000 and expenditure may be 17,000. So the data goes on like this for different persons, and the objective here is to represent the data in a matrix form like this. So age comes here, its corresponding income comes here, and the expenditure comes here. So is for the next person. And so on. So what we have done here is represented this table with the help of this matrix. And for further computation, this will be necessary because when we start implementing machine learning algorithms downstream, this will exactly be the representation we'll be looking for. Now, about the dimensions of a matrix, the dimensions of a matrix is always represented by rows into columns. So for matrix A, the dimensions are, A has 2 rows, so 2 cross, and it has 3 columns, so 2 cross 3 matrix. And similarly for this, if we had suppose 20 rows, then this matrix X will be represented as 20 cross 3 matrix. So I hope you get the intuition of what a matrix is, how to represent it. So let me move on with the next concept, that is vectors. A vector is simply an n by 1 matrix. So if I take for example a vector A, it can be represented as something like this. So A in this case is a 3 cross 1 vector. Now, what is the use of vectors? Suppose for the previous example, age, income, and expenditure, suppose we want to represent just this column, the age column. So we can try representing that with the help of this. And again, we'll leverage a lot of properties for vectors too, to ease our computation for machine learning. So this time I come to some of the mathematical operations we can perform on matrices. So suppose this is a matrix and I have to add this matrix to this. Now the resultant will be something like this. This is the first row and this is the first column. So if I assume this is A and this is B and I'm going to get a resultant C, I want to multiply the first row first column of A, add the first row first column of A to the first row first column of B, which gives me 1 plus 2, 3, and then this will get added to this. So here I have 1, this will get added to this. So I hope you see where this is going. I am just going to fill up the rest of the numbers. So 4 plus 6 equals 10, 5 plus 3 equals 8, and 6 plus 1 equals 7. So whenever we do addition of matrices, this is a 2 cross 3 matrix, this is again a 2 cross 3 matrix, and the resultant is also a 2 cross 3 matrix. Now what if we try to add something like this? So this is a 3 by 2, this is the 3 by 2 matrix, and I would like to add it to this. Now here's the thing with addition of matrices. You cannot add two matrices with dissimilar dimensions. So this will resort to an error. Ergo, this is not possible. Alright? Now, let me introduce to you another concept called scalar multiplication. So, a vector or a matrix, take any one for example, minus 1, 4, 3 suppose. Scalar multiplication is simply multiplying a single number with the whole of that matrix. So this will result to this number getting multiplied to each of these numbers. So this will give me 3 cross 2 equals 6, 3 cross 3 equals 9, and then 12 minus 3, 12, and 9. So this will be the resultant. We can also do some division. Suppose 27, and I want to divide it by 3. So this will result in the first element being 1, second element being 3, 9 divided by 3 is 3, the third element being 2/3, and the final element being 9. So we can combine some of these mathematical operations to maybe solve a problem of something like this. Suppose we want to do 2, 3, 4, minus 1, 2, 9. We want to add it to 3 into 1, 2, 1, 0, 3, 2, and then subtract it by 1, 3, 4, 7, 6, 5. So first off, let's just do this step. 3 cross 1 will be 3, 3 cross 2 will be 6, 3 cross 1 will be 3, and so on. So this will result to 3, 6, 3, 0, 9, and 6. And let the others be 6, 7, 5, 2, 3, 4, minus 1, 2, 9. So at this point in time we can choose to do any step. We can either multiply these two and then subtract this, or subtract these two and then add that to it. It will mean the same thing. So let me just go ahead with this addition first. So this plus this will be equal to 5, and then this plus this will be 9, 7, minus 1, 11, 15. This will be subtracted by this 7, 5. So this will result in 5 minus 1 this time, so which is equal to 4, 9 minus 3, which is equal to 6, 7 minus 4, 3, minus 1 minus 1 minus 6 will be equal to minus 7, and 11 minus 7, 4, 15 minus 5, 10. So that will be a combination of operands. Now again, a very interesting and important property to learn about matrices is a transpose. Now suppose I have this matrix 1, 2, 3, 4, 5, 6. Now assuming the value of A is this, A transpose, which is represented by A superscript T, will be equal to 1, 3, 5, 2, 4, 6. So let me explain this a little further. This is nothing but a 3 cross 2 matrix, right? So when we transpose, just like the meaning of the English word, we switch over its dimensions to 2 cross 3. So these will become the row 1, 3, 5, and this column would become the second row. So the second column becomes the second row, and thereby we have A transpose equals this. So I hope you got the point. So I'll move on. Now this will be the final step that we'll take towards linear algebra, and it's called matrix multiplication. So suppose I have matrix A, which is 2, 3, 4, 5, 1, 2, and I have matrix B, which is minus 1, 2, 3, 4, 2, 1. Now the dimensions of this matrix is of course 3 by 2, and this is 2 by 3. Now in matrix multiplication we need to keep one thing in mind. If we are trying to compute A cross B, then the number of columns for A has to be equal to the number of rows of B. If this is equal, then only matrix multiplication is possible. Otherwise it's not. So A and B are good candidates for being multiplied. So let's just take this one step at a time. So A cross B will be equal to what? So another thing to keep in mind is the result of a matrix multiplication is always this cross this. So just to get the intuition, if P by Q is the dimensions of the first matrix and Q by R is the dimension of the second matrix, then if we multiply these two matrices, then the resultant dimensions will be P by R, and this holds true always. So the way to multiply matrices is that, of course, now we know we're going to get a 3 by 3 matrix, so let me just fill that out with blanks. A 3 by 3 matrix. Now this first element would be this multiplied by this, so minus 2, and then this multiplied by this, plus 12 equal to 10. So what we basically did is multiplied the first row of A with the first column of B, and the resultant is plugged in over here, so this becomes a 10. Now for this element we would do something like this. 3 will be multiplied by 2, I'm sorry, 2, this element will be multiplied by 2, which is 4, and 3 will be multiplied by this element, which is 6, so which is again a 10. And for this element, these 2 and 3 will be multiplied by 3 and 1, so we get 2 into 3, which is 6, plus 3 into 1, which is 3, which is equal to 9, so we just plug that number in over here. So just going by this, I think we can fill in these matrices. So let me just do one additional step. So this element will be this into this, which is minus 4 plus 5 into this 4 plus 4, which is 0. So here we plug in 0. So the basic intuition is, if we index this matrix like this, so for element 1 1 we will multiply the first row of A with the first column of 1. For this element we'll multiply the first column of A, the first row of A with the second column of B, and for this element we'll again multiply the first row of A with the third column of B. Likewise, the second row of A will be multiplied by the first column of B, the second row of A will be multiplied by the second column of B to get this number, and suppose for this number we will multiply the third row of A, so these two numbers will be multiplied by the second column of B by this. So this will be multiplied by this. 1 times 2 will be 2, and 2 times 2 will be 4, get 6, so we plug in this number over here. So I guess now many of you might have known this beforehand, so I just wanted you to revise that. And for those who don't know, if it seems a little difficult, then don't worry about it. I mean, we don't need to do this hand computation every time, but then it is very important to understand how these concepts work, so that if need be, we can tweak some of these numbers around to get efficacious results. So this is me, Vivek, from Ivy Professional School, signing off. Hope to see you soon again. Enjoy.